Okay, good morning, everyone. So today we'll continue our discussion about proving the validity or invalidity of quantified arguments or arguments involving quantified predicates. And then we'll also try to start our discussion of methods of proof. All right. Pero siguro dito yata tayo natapos last time when I said I'm not sure what remark number 4 or this statement number 4 means. Sabi dito, don't use an existential instantiation or a universal generalization on a singular statement. And I was thinking what it meant, pero that pala binasa ko yung examples, so it might be easier. So it's just saying you cannot just use existential instantiation to a very specific element of the domain without a knowledge of indeed that specific element of the domain satisfied the um, the uh, the proposition or the predicate that is quantified existentially. So halimbawa, yung example ng invalid reasoning number 1 ay etong statement number 1 dito, someone went to the party, therefore April went to the party. So all we know from the first statement is there exists a person that went to the party, all right? Pero mali na mag-instantiate ka to a specific person, say April, unless you have prior knowledge that indeed April went to the party. So, in the absence of any information, kung ang alam lang natin ay someone went to the party, it would be erroneous or fallacious to conclude that therefore that April went to the party. Kasi nga hindi natin sure, wala tayong info whether indeed April went to the party or not. All we know is that somebody went to the party. Okay? And then, so parang false accusation yung number 1. Okay? So, hindi ka pwedeng mag-EI kapag ka hindi ka sigurado ng specific constant that you are referring to really indeed is one of those elements of the domain that satisfies the predicate. Okay? And then the second one is do not use a single person or a single subject to invoke universal generalization. So look at statement number 2. April went to the party. And then it would be erroneous to conclude that everybody went to the party. Kasi ang alam lang natin si April nagpunta sa party. So that doesn't mean that all persons in the domain went to the party. So hindi ka pwedeng mag-UG, right? Di ba nasabi na natin to last time, bawal kang mag-UG kapag ka nanggaling ka sa isang specific or non-arbitrary element of the domain. In this case, our premise is that April went to the party. April is a non-generic element of the domain, so therefore hindi tayo pwedeng mag-UG. All we can do is to use EG. So dapat ang conclusion dito, somebody went to the party. Okay? So I guess that completes our discussion ng mga fallacious or erroneous uh, arguments or reasoning whenever dealing with quantified propositions. Okay. Now we'll start talking about proving invalidity of quantified propositions. Again, remember we say that that an argument is valid if and only if true premises or assuming that the premises are true will lead us to a true conclusion. Okay. So, kung gusto nating i-prove na ang statement ay, ang isang argument ay invalid, dapat mapakita natin na it is possible. So, invalid ang isang argument. If it is possible to find instances wherein the premises are all true, but the conclusion is false. So, di ba ginawa na rin natin to last time. So, kapag nakapag-demonstrate tayo ng possibility o ng at least isang case wherein the premises are all true pero yung conclusion ay false, then we say that the argument is invalid. Okay? Or the structure of the argument is not logically valid. Remember, the basis for this is the definition of a valid argument. We say that an argument is valid if premise 1 and premise 2 and premise 3 and so on until your last premise implies your conclusion, right? So, we want to show that this is a tautology para maging valid yung argument. So it will be invalid if this is not a tautology, meaning there is a specific instance such that this premises are this conjunction of the premises is true, but the conclusion is false. Kasi remember, sa conditional, pagka meron kang true antecedent tapos false consequent, ibig sabihin false yung buong conditional statement. Okay. Now, proving invalidity of quantified arguments or arguments involving quantified predicates is a little bit trickier than just proving it for general types of propositions na ginawa natin last time. Kasi ngayon, kailangan nating tingnan maraming posibleng cases yung there exists at saka for all, right? So there exists, may isa lang specific, sa for all, nag-hold siya sa lahat. And usually what we want to do is to inspect the different cases or different scenarios wherein we create some models for our universe. Okay. Now, ang idea rito ay magsimula tayo sa pinakamaliit na posibleng universe and show that that universe or that model for our domain and then the statements applied to that model will lead us to true premises implying a false conclusion. Okay. So, sisimulan natin siya sa one element model, pakita or i-check kung posible nga ba na meron kang true implying false. Pagka valid siya sa one element model, kunwari yung universe natin may dalawang elements and let's see what will happen. Okay. Now, let's try to illustrate what I am describing. Look at example 39. So here we were specifically told that the argument is invalid. Kailangan natin ng proof of invalidity. Now, here's the statement. Here's the argument. Some dogs are black. All Dalmatians are dogs. Therefore, some Dalmatians are black. So again, we start with declaring our variables. So we let statement B about X be X is a dog. Statement B about X is black. Statement M about X is a Dalmatian. Okay. Now, statement some dogs are black, so there exists some X's in the universe such that X is a dog and it is black at the same time. So yun yung first translation ng first sentence. All Dalmatians are dogs. So automatic daw na kapag ka Dalmatian, dog siya kagad, right? So our second premise, for all element X in the universe or in the domain, being a Dalmatian implies X is a dog. Okay. And then the conclusion, marked by the word therefore, some Dalmatians, so some means we have a there exists, Dalmatians are black. So ibig sabihin kapag si X ay Dalmatian, pwedeng mangyari na siya ay black at the same time. So our conclusion is again a conjunction. Okay. Sabi ko kanina, medyo mahirap i-prove yung invalidity. So kailangan nating tingnan exhaustively or i-check yung possibility of getting true premises and yet a false conclusion. Okay? So we start with the simplest model. Kunwari, isa lang yung element ng domain. Okay? And that's what we call a one-element model. So, oh, sorry. So here, okay. So here we instantiated the argument sa isang element A ng single element domain. So ito yung tinatawag nating one element model. So let's look at a one element model. Again, when I say one element model, ibig sabihin ina-assume natin na isa lamang yung element ng domain. Kasi if you look at the statement or the argument, walang sinabi kung ilan yung laman ilan yung laman ng domain. Dahil walang sinabi kung ilan yung laman ng domain, ibig sabihin it will hold whether our domain will have one or more number of elements. Okay. So dapat mag-hold siya kahit ilan yung laman ng domain. So para ma-prove na merong possibility na true premises implying false conclusion, let's try to see ano yung nangyayari kapag yung universe o yung domain, isa lang yung laman. And if the statement is valid, then we expect to get true implying true. Pero if we'll be able to show that in a one-element model or in a domain with only one element, there is a possibility of getting true premises implying a false conclusion, then we can conclude that automatically the argument is invalid. Okay? So dito sa one element model na to, inassume ko na yung domain ay set containing A lang. Kunwari, isa lang yung X na posible kong i-substitute dun sa statements. So let's see. I-instantiate ko lang siya sa specific element A. So look at statement first premise. In the first premise, we see that here, sinabi there exists an X such that dx and v of x. Ang kagandahan sa model natin, isa lang yung laman niya. Right? Isa lang yung laman ng domain. Eh sabi ng premise number 1, there exists an X coming from the domain such that this conjunction is true. So meron nag-exist, kaya lang dun sa universe natin, isa lang yung laman. So ibig sabihin, automatically, mag-hold ito kay element A. Right? And that's why I know for a fact that DA and BA is true. Kasi kung hindi totoo yung conjunction na yan kay A, then premise number 1 will be forced to be false, right? Kasi isang lang yung element ng domain, so dapat yung existence o yung existentially quantified predicate mag-hold dun sa nag-iisang element ng domain, right? So this is assumed to be true. And then, yung second statement, wala tayong problema kasi for all X. So, kahit ilan pa yung laman ng universe, mag-hold siya sa kahit anong element ng universe. In this case, we only have one element, so we know that MA must imply DA. Right? And again, this must be assumed to be true. And then we are looking for a case wherein we get a false conclusion. Kasi sinabi sa instruction to prove invalidity of this statement. So sure tayo na invalid yung statement, hinahanapan lang natin ng proof. So we must demonstrate the possibility, or at least one case, that we have true premises implying false conclusion. Okay? Kasi dito medyo maglalaro tayo, parang magiging puzzle ito, right? So tingnan natin, dapat daw maging false yung conclusion while the premises are all true. Siguro i-fill up nyo muna yung truth value ng mga wala tayong options. Like, kung tingnan nyo kasi yung conclusion, paano magiging false si conclusion? Magiging false si conclusion kapag ka at least isa dito sa dalawa ay naging false, right? That's the time when a conjunction becomes false, when at least one of its conjuncts is false. Kaya lang, merong mga possibilities, either si M yung false lang, or si B yung false lang, o kaya parehas silang false. So there are 3 possibilities for assigning truth values to the conclusion to make it false. So, iwan ko muna yon. Tingnan ko muna kung may mas madaling assignment akong pwedeng gawin. Now, look at the first premise. Dapat daw true yung conjunction. Para maging true yung conjunction, dapat true parehas ng conjuncts. So, dapat true si D at true rin si B. Okay? And here I know, dun sa conclusion, dapat true daw si B. So, true dapat ito. Pero gusto natin false yung conjunction. So, we don't have any choice but to assume that M is false. Right? Kasi M daw dapat ay false. Para maging false yung conclusion. Right? So, tingnan natin kung posible ba to. If we will be able to find truth value assignments to the second premise, keeping it true, then we have proven that the argument is invalid. Okay. Now, anong alam natin sa second premise? Sa second premise, alam ko si D ay true. Oh, I have here a true consequent. So it doesn't matter what the truth value of the antecedent is. Pero alam na pala natin na dapat i-force natin si M to be false. So M is false. So the second premise is a false statement implying a true statement. And this implication is still true, right? Kasi false implying true. So here we have demonstrated a possibility or one specific case wherein the premises are all true but the conclusion is false. So therefore we can say it is invalid. So in order to formalize your proof, kailangan nyo lang i-specify yung findings natin dito, yung analysis natin dito. You can say that probably, sulat ko na lang dito. So using a one-element model, with an element A of the domain, then we can assign the following truth values, So specify nyo lang, ano yung mga truth values dun sa mga propositions, right? So mga specified propositions para maging true implying false. So I guess here we assign B of A to be true. Oops. We assign B of A to be true as well. And then M of A is true. Is false. So nakakita tayo ng isang specific case na magkakaroon ng true implying false, so the argument is invalid. So this will lead to true premises implying a false conclusion. Therefore, the argument is invalid. Okay? So, medyo masayang mag-prove ng invalidity kasi parang nagsosolve ka ng puzzle. Pero kapag ka medyo marami ng propositions involved, tapos hindi na siya nag-hold sa one element model, medyo magiging tedious yung pag-check ng invalidity. Kasi nga ang problema natin dito, quantified yung mga predicates. Okay? Now, is the process making sense? Okay. So let's look at a more complicated example. Tingnan natin tong, okay. So example 41. So example 41, we have the following statements. All generals are rich. Some intellectuals are rich. Therefore, all generals are intellectuals. So we have the following variables used. G about X, X is a general. R about X, X is rich. I of X, X is an intellectual, right? Then, pag translate natin yan, all generals are rich. Therefore, if X is a person, being a general is sufficient to become rich. So kaya conditional, yung translation ng statement 1. And then some intellectuals are rich. So there exist some persons that are intellectual and rich at the same time. So there exists an X such that I of X and R of X. Therefore, all generals are intellectual. So, ang gustong sabihin nung conclusion, kapag ka general ka, intellectual ka daw automatically. So that means for all persons X, being a general is sufficient to conclude being an intellectual. Okay? So, ito yung argument. Tingnan natin kung siya ay valid. Now again, actually sinabi na pala na ito ay invalid. So, para i-prove yung invalidity niya, again, we look at models for our domain. Walang sinabi kung ilan yung laman ng domain. So, in math, pag walang restriction, ibig sabihin mag-hold siya sa sa domain na may kahit ilang elements. So, suppose natin one element model, isa lang yung laman ng domain. Okay. So, kung isa lang yung laman ng domain, tapos ang laman niya lang ay si A, then yung for all, mag-hold siya kay A. Yung there exists, mag-hold din siya kay A kasi isa nga lang yung element ng universe. So, there exists daw. Isa lang yung element. So, isa lang yung choice kung kanino mag-hold yung premise number 2. So, we are forced to say I of A and R of A is true. And the conclusion for all X, so this will be true also for A. Okay? Now, this argument is actually this argument specified to the element A of our single universe domain is valid. Madali ba siyang ipakita na valid? Yeah, probably I can leave this as an exercise to you para ipakita na siya ay valid. Let's see. Yeah, I think you'll just need to use material implication and some simplifications here. So, but eventually, you'll be able to show that this argument is valid. Ito na yung problema. Sa one element model, nag-hold yung statement. Yes, Gad, you have a question?
Wala, napindot lang po. Excited.
Okay, no problem, Gad. All right. So, yeah. Ito ay valid. So sa kapag ka yung domain ay isa lang yung laman, valid yung argument. Okay. So sabi alam natin in the beginning invalid to. So there should be a universe somewhere na invalid yung statement. So sunod natin tingnan kung nag-hold siya sa one element model, tingnan natin kung mag-hold siya sa isang two element model. Sa isang domain na dalawa yung laman. Maybe we can do that here. So we consider a two element model. So suppose the domain is the set containing little a and little b. So kunwari, dalawa lang yung laman ng universe para madali siyang i-analyze. Okay. Now, let's see. How do we specify the quantified predicates? Look at statement number one. Premise number one. Premise number one, sabi niya, for all x, g of x implies r of x. Dalawa yung laman ng universe natin. So, ibig sabihin, yung g of x implying r of x should hold for both a and b. Kasi totoo siya for all x. Meron tayong dalawang posibleng values ni x, a and b. So, dapat parehas maging true yung premise number one kay a and b. So, I can specify it as g of a implying R of A and G of B implying R of B. Right? Kasi nga, true siya for all. So, totoo siya dapat kay A and totoo siya dapat kay B. Alright? And then sa test of validity, gusto natin maging true tong statement na to. Okay? Now, using let's go to premise number two, wherein we have an existential quantifier. Ang sabi ng statement number two, there exists an x such that I of x and R of x. So meron daw nag-exist na element ng domain na totoo yung Ix and Rx. Pero ilan yung laman ng domain natin? Meron tayong dalawang laman ng domain. So ibig sabihin, posibleng totoo yung premise number 2 kay A o kaya totoo siya kay B. Pwede rin naman totoo siya sa parehas. Ang hindi lang pwedeng mangyari ay hindi siya totoo dun sa parehas. Okay? But the problem here is A and B are random elements of the universe. We don't know exactly for which of those two will premise number 2 be true. Alright? So kaya ang pwede nating i-conclude at most, dahil daw may nag-exist. So ibig sabihin, either I of A and R of A or I of B and R of B. And take note that the connective I used here is or. Or siya kasi hindi ko alam kung kanino nag-hold yung existentially quantified predicate. Totoo ba siya kay A o totoo ba siya kay B? So, pero alam ko at least isa sa kanila ay true, right? So that's the use of or. So in summary, if you're instantiating a universally quantified predicate to multiple elements of the domain, the connective should always be an and. Totoo siya sa lahat. So dapat totoo siya sa lahat. So and yung ginagamit na connective. Now, if you have an existential quantifier and you want to specify it to all elements of the domain, well, you can do so, but the connective should be an or. Kasi hindi tayo sure kung kanino siya nag-hold. Hindi tayo sure kung nag-hold siya sa lahat. Sigurado lang tayo nag-hold siya sa at least isa. Right? Kaya or yung ginagamit dito. And again, for the sake of checking validity or invalidity, we will assume that this is true. And then the conclusion? Ang conclusion ay true for all Dahil true daw siya for all, ibig sabihin, magkakaroon tayo ng G of A implying I of A and G of B implying I of B. Kasi nga true siya sa lahat, so totoo siya sa parehas na A and B. That's why the connective and. And again, checking invalidity, we want to show that it is possible that even though the premises are true, the conclusion will be false. All right? Tapos ito, mag-solve na tayo ng puzzle. Gusto natin true yung premises, pero gusto natin maging false yung conclusion. Medyo mas maraming cases yung false conclusion kasi end uli yung conclusion. So, posibleng ito yung false, posibleng ito lang yung false, or posible rin na parehas na sila ay false. So, medyo maraming posibilidad doon. Puntahan ko siguro ano mas madaling mag-assign. Pwede ako magpunta sa statement number 1 muna. Right? Kasi dapat maging true yung conjunction. So, para maging true yung conjunction, dapat true sila parehas. So, para maging true, so dapat true ito, true din ito. Now, let's see. Dapat true siya. Marami pa rin palang possibilities, no? Kasi yung implication nagiging true kapag except kapag true implying false. So, there's still a lot of options here. Siguro, mag-try ako ng some specific case and hopefully I'll get lucky. So, let's try true implying true, kunwari. Tingnan ko kung magkakaproblema ako. So, true si G of A, tapos true kunwari si R of A. Okay? So, that makes the implication true. So, ibig sabihin, lahat ng G of A, pwede ko nang i-label to be true. So, this must be true. The R of A dapat daw ay true. Tapos, ano pa? Yun pa lang, no? And then siguro pwede ko nang i-try. Pwede ko na bang gawing false si I of A? Para meron na kagad akong true implying false dun sa conclusion. False na kagad si conclusion. Alright? Kaya lang, kakaproblema ako doon kasi magiging false ito. Pwede pa rin pala, no? Pwede pa rin magiging false si I of A. Kasi pag si I of A ay false, etong statement na to ay magiging false. Pero okay lang kasi gusto kong connected naman sila by an or. So, posibleng false ito, pero ito dapat maging true. Right? So, dapat true yung second disjunct dun sa second premise. So, para maging true yan, dapat true si I of B at true si R of B. True si R of B, so totoo to. So, totoo si I of B, so true siya. Then si G of B ay walang restriction kay G of B, right? So si G of B dapat dito ay pwede kong gawing true. Tapos true rin siya dito. Okay. And did we get any contradiction? I think we're fine. Tama nga ba? So true yung, with this truth value assignments, true yung first true yung first premise, true yung second premise, pero false yung conclusion. Right? Kasi false yung first conjunct dun sa conclusion. Okay. So now we have demonstrated the possibility in a two-element model that the proposition that the argument is invalid. Therefore, the argument in general would be invalid. Okay. So maybe you can formalize your statement here. So we can say in a two-element model, consisting of A and B, assigning the following truth values. Leads to true premises, but false conclusion. So siguro i-require namin na gawan nyo ng table, so na summary ng truth values. So pwedeng nandito yung G of A, R of A, I of A, then G of B, R of B, I of A, then yung truth values nila. So nandito yung propositions. Okay, yung specified propositions. So si GA ay true, si RA ay ginawa nating true, si IA ay ginawa nating false, tapos lahat ng statement about B ay ginawa nating true. Okay. So since this truth value assignments to the specified propositions in the two-element model will make the conclusion false, even though the premises are true, then we can say therefore the argument is invalid. Okay? Ang problema, kapag ka meron kang two-element model, tapos kunwari naging valid pa rin yung argument, then you need to jump to a three-element model. Tapos magiging masyado na siyang komplikado, right? I hope you can see the picture. Pero I guess sa Math 101, we just stick to at most or proving of invalidity to statements hanggang two-element models. So hopefully, sa two-element models makakita na kayo ng some specific case na invalid siya. Okay? Is the process clear? Any questions? Yes, Daniel?
Good morning. Good morning po. In case na hindi na true siya, the arguments are true for only one element, 2, 3, how would we know when to stop po?
Good question. Actually, pero gagawin mo lang naman tong test na to kapag ka sure ka na invalid siya or sinabi dun sa problem na invalid siya. Kung totoo siya sa 1, totoo siya sa 2, totoo siya sa 3, totoo siya sa 4, pero alam mo pa rin na invalid siya, then you have no choice but to still search for that universe with this specific number of elements kung saan magkakaroon ka ng true implying false. So, question, kailan ka mag-stop? Mag-stop kapag may nakita ka ng example. Pero hanggat wala ka pa nakikita, pero sure ka talaga na invalid siya, then you have no choice but to continue your search. Okay? Yun yung dito sa quantified arguments, mas mahirap actually na i-prove na invalid kaysa ipakita na siya ay valid. Kasi kung valid siya, ibig sabihin totoo siya sa lahat ng elements, sa lahat ng possible universes. So, yung rules of inference at saka yung rules of equivalence will aid us in order to show na valid siya. Pero yung invalidity, we are searching for a specific universe among infinitely many ones kung saan magiging invalid yung statement, which is a very hard task. So, yeah. Hindi ka mag-stop hanggang wala kang makitang counterexample. All right? So, and then this should make us appreciate the power of math. Na parang mas, pag gumamit ka ng logic, nakakapagawa ka ng proof na totoo siya sa lahat ng possibilities, sa lahat ng possible universes, like what we did for proof of validities last time. Kung napansin nyo, I didn't care to look at a one-element model, two-element model, three-element model, or a 10-element model dun sa mga valid arguments na nakita natin last time. But through the rules of inference and the rules of equivalence that we used last time, napakita natin na hindi nagmamatter kung ilan yung laman ng domain. Lagi pa ring valid yung argument na yon. And we are talking about infinitely many universes kasi napakaraming possibilities or infinite yung possibilities kung ilan yung laman ng universe. So that's the power that mathematical proofs gives us. All right? Yun yung problema sa invalidity. Kailangang i-test talaga natin kailan tayo saang universe nagiging invalid yung argument. Okay? So yeah, that's the sad answer to your question, Daniel. You cannot stop. Pero dapat sure ka na invalid Kasi kung valid siya kahit ilan yung i-test mo, lagi pa rin siya magiging true. Okay. And then the truth value assignments or your examples might be different. So incidentally, meron palang sagot dito sa module. Ito yung truth value assignments niya, which is different from what we got, right? So ang false sa kanya ay si I of B. So it doesn't matter. We can have different answers as long as true implying false pa rin. Okay? So kaya kanya-kanya. That's why we will really appreciate if you will construct a table like this din sa inyong mga isa-submit para mas madali naming makita paano nyo siya inassign yung truth value. Pero I usually find it easier for the analysis kung gagawa ko ng ganitong tabulation. Alright, so para makita ko yung possibilities. Okay? Any other questions? Oh, yes, Gad?
Sir, no question. Okay lang pa.
Sure. Yeah.
Yung sa makikitaas nga po, sir.
Uh-huh.
Kanti pa po. Kanti pa po. Ayan, yun po. Yung pag po ba universally quantified po, pag po inano namin siya in symbol, implication na po siya. Tapos kapag naman po existential, conjunction po. Tama po ba intindi ko, sir? Or depende pa rin po yun?
Depende pa rin siya sa statement. So kaya kailangang i-analyze niyo yung statement. So tingnan natin, halimbawa. Pero most likely ganun nga yung nangyayari, no, based on the examples that we have seen. Though ayokong i-generalize. Pero tingnan natin uli yung example 41. All generals are rich. So sabi dito, lahat ng general ay rich. So ibig sabihin, kapag ka general ka, automatic na nagiging rich ka. So ibig sabihin, it is sufficient to become it is sufficient that you are a general to imply na ikaw ay rich at the same time. So, ibig sabihin, si G ay sufficient para mo conclude na si R ay totoo. Now, in contrast to this one, some intellectuals are rich. So, meron daw mga persons na intellectual and rich at the same time. Kaya and yung ginagamit. Pero I guess, yeah, most likely, kapag universally quantified, pero depende pa rin, no? Kasi pwedeng halimbawa yung statement natin ay, hold on, nag-iisip ako ng example. Yeah, wala akong maisip na example na hindi nagiging implication yung for all. Pero I guess, Gad, magiging clear siya pag in-analyze niyo yung statement. And most likely, nagiging, pag universally quantified, tapos ganito yung tipo ng statement, nagiging conditional siya. Okay. I just can't think of a specific case wherein kailangan talaga conjunction sa for all. Pero yun yung power kasi ng statement about everything. So parang nagiging sufficient yung first statement to conclude the next statement. Okay?
Okay,
Pero
sir.
yeah, kailangan talagang kapain yung statements kung ano yung gustong sabihin ng particular statement.
Okay po. Thank you po.
All right. Okay, anybody else who has a question? Okay, wala na. So okay, so if that's if you don't have any questions, then let's go to section 1.5 in the work text, which is about the methods of proof. I consider this to be the most important part of Math 101 kasi ito talaga yung bedrock ng magiging career nyo as a mathematician or as an applied mathematician. You will be writing a lot of proofs, right? And usually the proofs that you will write are more informal in nature rather than the formal two-column proof that we have seen whenever we prove validity or nung nag-prove kayo ng geometric ideas in your high school geometry classes. So ngayon parang nagkikwento ka. There's a statement, there's a theorem, there's a statement that you want to prove. So you need to be able to convince the reader that your statement is true without a shadow of a doubt. So yung burden of proof sa atin ay mas mataas kaysa sa burden of proof say sa criminal justice system na beyond reasonable doubt lang. Sa atin sa math, lagi natin gustong i-prove ang isang statement beyond any doubt. Okay? The problem about proving is that I don't think there is a foolproof algorithm or process that you need to follow para ma-prove ang isang statement. It is actually a test of creativity and how you apply mathematical ideas or previously proven ideas or statements in order to establish the truthfulness of your instant theorem or your instant statement. So kaya sa tingin ko, ito yung isa sa mga pinaka-challenging na ituro. Paano ka nagpo-prove? Kasi nga, you build the intuition on how to prove a certain statement by doing a lot of proofs. So madedevelop nyo through time yung instinct on how to find the proof. So at best, what we can offer as teachers, at least in Math 101, is to present to you several ideas on how to prove, or generic ideas on how to prove statements of certain forms. Pero hindi pa rin to foolproof. So, big sabihin, posible na iba yung kailangan nyo gamitin whenever you encounter a specific statement. Pero generally, ito yung mga nag-work. O ito yung pwede nyo unang itry para ma-prove yung mga statements. Okay. So, and then this will be very important kasi gagamitin nyo to not only for the second part of Math 101, which is set theory, but you will also use it in succeeding courses. Kaya medyo tricky na maging Math 101 teacher or medyo may konting inhibitions ang mga faculty members na maging Math 101 teachers. Kasi pagka pumunta na kayo sa Math 155, Math 174, or what higher math or applied math courses it is, lagi kayo nagpo-prove. Tapos pag hindi kayo marunong mag-prove, laging babalik. Sino bang teacher niya ng 101? So, tatandaan ko lahat kayo. Tapos pag merong teacher na nagreklamo na hindi kayo marunong mag-prove, hahantingin ko kayo, right? So, maglilianisan ako na I will hunt you down and so on. So, yeah. Actually, pag may mga nag-a-apply na faculty members din na naging estudyante ko, medyo kinakabahan din ako. Baka may masabi silang mali sa teaching demo. Tapos sabi, sino bang teacher niya ng 101 o ng 36? But anyway. So, galingan nyo guys ha. Competitive pa naman ako. So, ayokong may marinig tungkol sa inyo na hindi kayo marunong mag-prove after the class. So, pagtrabahuhan natin. But again, the goal is to try to prove as many statements as possible, because that's the only way that you develop your proving instincts, okay? Now, let's look at specific cases to give you some ideas or some at least preliminary steps or preliminary things that you can try para ma-prove yung mga certain statements. Now, I guess the first part is to write existence proofs. So, ginagamit natin itong klase ng proof na to kapag gusto natin i-prove na yung isang statement that claims the existence of something, right? And the easiest way to do that is to prove it via example. Again, this will only work kapag yung theorem or yung statement that you want to prove claims the existence of a particular element of the domain. Dahil ang kiniklaim niya lang naman ay existence, so ibig sabihin sufficient na magpakita ka ng isang example na nakakasatisfy ng theorem. So let's look at one particular example. Example 1. Prove that there exists an even integer which is prime. Kunwari, hindi nyo pa nakikita yung proof. So prove that there exists an integer which is prime. Existence lang yung pinapa-prove. So it will be sufficient to give an example of an even integer that is prime. And that completes the proof. Kasi ito yung isa sa mga pinaka-simple probably na type of theorems that you will be proving, existence. So kailangan mag-construct ka o magbigay ka ng isang example. And in example number 1, it's easy. Magbigay ka lang, x equals 2. Then that's it. That's your proof, right? So you can say, actually, masyado pang formal yung statement dito sa word text. Pwede nyo lang sabihin na, okay, so consider the integer 2. 2 is even and it is prime at the same time. So therefore, there exists an even integer which is prime and a proof. Okay? So proof by example or proof by construction. Nagko-construct kayo ng isang example kasi existence lang naman yung kiniklaim sa theorem. Okay? Now, example 3 is a theorem claiming the existence of two integers, x and y, such that 3x plus 4y equals 24. Again, existence ulit. So dahil ang statement ay existence, kailangan makapagbigay tayo ng x at y na nakakasatisfy ng statement, right? So 3x plus 4y equals 24. Existence daw ng integers x and y. So mag-construct tayo o magbigay tayo ng examples ng integers x and y that satisfies 3x plus 4y equals 24. So sabi dito sa proof niya, take x equals 4 and y equals 3. Then pag pinlogin mo siya, magkakaroon ka ng 3x plus 4y equals to 24. Okay, and that would be fine. Okay. Again, masyadong formal yung pagkaka-state ng proof dun sa word text. Pwedeng ganito na lang yung proof nyo. So proof, you can say consider integers x equals 4 and y equals 3. Note that 3x plus 4y equals 3 times 4 plus 4 times 3 equals 12 plus 12 equals 24. And the proof. Okay? So kasi napakita natin na may nag-exist na dalawang integers, namely 4 and 3, such that 3x plus 4y equals 24. Okay? So pwedeng ganito lang kasimple yung proof. Pakita nyo, magbigay kayo ng example. Kine-claim ng theorem, may nag-exist na x and y. So magbigay ako ng x and y na integers. Okay? Tapos pakita ko na nasa-satisfy niya yung kine-claim sa theorem. Kinlaim ng theorem na 3x plus 4y ay 24. So pakita ko lang na nasa-satisfy nung binigay kong example yung 3x plus 4y equals 24. Okay? Now, whenever doing this, lagi kayo mag-work with one side of the equation, then pakita niyo yung kabila. This is a common problem that I notice even for math teachers from high school. Kasi ganito yung ginagawa natin ng high school, no? Yung nag-start ka sa dalawang sides ng equation to prove a certain identity. I don't know kung ganun pa rin yung ginagawa niyo sa high school, pero I taught some classes ng estudyante ko ay mga math teachers. Ginagawa nila to, pero siguro familiar din kayo. So gusto niyang ipakita na 3x plus 4y equals 24. So ang ginagawa natin ng high school, or ginawa namin ng high school, pinlagin ko lang yung x equals 4 at saka y equals 3. Tapos nilalagyan pa ngayon ng question mark sa taas. Ginawa niyo rin ba to? Tapos susunod, 12 plus 12 equals 24. Tapos 24 equals 24. Lalagyan ng check. Right? So tapos ito daw yung proof. Now, formally, in formal math, we don't accept such a proof. Kasi remember, sinusulat mo lang sa proof kapag ka-sure ka na totoo. So you cannot write this in your proof because we haven't established that 3x plus 4y equals 24 from the get-go. Di pa natin alam kung totoo siya. Siya nga yung gusto nating ipakita to be true. So ibig sabihin, di ko siya pwedeng gamitin sa proof. So nowhere in your proof should I see what is to be proven. Okay? Pwede yung sabihin, sir, nilagyan ko naman ng question mark yung equal sign dito. Well, that is not a formal math symbol. So kaya avoid using an equation to prove itself. Right? Kasi parang, gusto nyo sabihin, totoo si statement P, tapos sisimulan nyo ng proof, assume natin na totoo si statement P. And that doesn't make any sense. All right? So the safer way, or actually the correct way, is to work with one side of the equation, manipulate it in order to get the desired right-hand side. Okay? Right. So, yeah. So, tanggalin natin to. Kung natutunan natin yan from high school, let's just forget about it and do it the right way, or the more mathematically accepted way. All right? So, is it okay, guys, if I borrow 5 more minutes to cover some more examples? Okay. Thank you. So, sa existence, so isang way para ma-prove nga yung existence theorem is to indeed demonstrate na may nag-exist. So we can give an example or we can construct an example, right? Pero hindi naman palagi na kailangan magpakita ka ng isang particular example. So, posible na gumamit ka ng mga established theorems para mapakita na totoo yung isang state, right? For instance, example 6. Sa example 6, ang pinapaprove ay let f be a function or be the function x squared minus 2x minus 3. And we want to prove that there exists a real number c between 0 and 3 inclusive such that f of c is equal to -1. So, kiniklaim niya may nag-exist na c sa pagitan ni 0 and 3 such that f of c equals -1. Well, one way to write the proof is to give me explicitly what the number c satisfies the theorem, right? So yun yung proof by construction natin kanina. Ibigay niyo sa akin ano si c. I just need to make sure that c is strictly c is between 0 and 3 inclusive and f of c is equal to -1, right? So kung gusto ko yung proof by construction kanina, pwedeng gawin ko ay f of c. So pwedeng I'll solve for c. F of c equals -1. Tama ba? Then this is f of c would be c squared minus 2c minus 3 equals -1. All right? And then pwede ko siyang isulat na c squared minus 2c minus 2 equals 0. Tama bang algebra ko? Maaga pa, so baka meron akong algebraic error. Sana tama. Factorable ba to? Mukhang hindi siya factorable, so quadratic formula ko. C equals plus or minus c equals -b plus or minus square root of b squared minus 4ac all over 2a. Tama ba? -b squared minus 4ac, so -8 minus 8. So I think this is right. So we'll get 2 plus or minus square root of 12 over 2. And this would be 2 plus or minus 2 root 3 over 2. So this would be 1 plus or minus 2 root 3. Okay. Tama ba yung computation ko? Parang mali. Let me see. Okay. Tama pala. 1 lang to. Plus or minus root 3. All right. So, and then, dalawa yung options natin. May nakita tayong dalawang c such that f of c is equal to -1. However, the theorem requires c to be between 0 and 3. Note na ang 1 minus root 3 ay negative kasi mas malaki si root 3 kaysa kay root 1. Alright? So this would be negative, pero sure tayo na yung 1 plus root 3 ay greater than 0, but this is less than 3. Kasi ang root of 3 is 1 point something plus 1, so that's going to be 2 point something, mas maliit siya kay 3. So you can write your proof by saying you can take c to be 1 plus root 3. Pakita nyo lang na, or sabihin nyo lang na si 1 plus root 3 ay between 0 and 3. Tapos pag pinlog-in nyo to dun sa f, makukuha nyo ay -1. Right? So that's proof by construction. But sometimes proving by construction is hard. So pwede naman kasing gumamit tayo ng previously established results like the intermediate value theorem. So if you remember from calculus, sa intermediate value theorem, ang sabi niya, kapag ka meron kang continuous function on the interval AB, tapos yung f of A, siguro drawing ko na lang yung IVT para maalala nyo. So kung meron kang function na continuous, ito si y equals f of x. Remember, kung continuous si function, ibig sabihin kaya niyo siyang i-drawing na hindi aangat yung pen, right? Tapos, meron kang interval AB, right? Ang sinasabi niya lang ay, sa kahit anong number, sa pagitan ni f of A at saka ni f of B, lipat ko na lang si f of B, si B. Ito na lang si B, para mas maganda yung example. So, sa kahit anong number daw sa pagitan ni f of A at ni f of B, so ito si f of A, Tapos ito si f of b. Kahit na anong number sa pagitan ni f of a at ni f of b, so kahit anong nasa pagitan nilang dalawa, may nag-exist daw na number c sa pagitan ni a and b such that f of c is equal to that number. So, halimbawa, may number u ka dito. Lagi ka daw may makikitang element ng interval AB ng f of u ay equal kay u. Ang f of c ay equal kay u. So that number c is this. Kasi dito ang f of c ay equal kay u. Kasi nga kailangan nating i-drawing yung graph ni f na hindi angat yung pen natin. So ibig sabihin, sa kahit na anong value na dadaanan ng graph ni f, right? So coming from f of a to f of b, laging may nag-exist na number dun sa domain sa pagitan ni a and b such that f of c is equal to u. Alright? So we can use this fact in order to demonstrate na kailangan talagang may mag-exist na number c without giving explicitly what that value of c is. Okay? So kaya ganito yung proof dun sa vortex. So first, sinabi niyo na si f ay continuous because it is a polynomial. So being a polynomial function, si f ay continuous everywhere. So ibig sabihin, continuous siya sa interval 0 to 3 kasi ang hinahanap natin na c ay sa pagitan ni 0 and 3. And then we look at f of 0 and f of 3. Ang sabi ng intermediate value theorem, sa kahit anong number sa pagitan ni -3 at ni 0, may nag-exist na element ng domain, let's call it c, such that f of c is equal to that number. And definitely -1 is between -3 and 0. So by the intermediate value theorem, there should exist a number c on the interval 0, 3 such that f of c is equal to -1. And this is acceptable proof kasi ginamit natin yung existing result from calculus. So hindi kailangan na laging mag-demonstrate ng existence. So pwedeng gumamit ka ng previous results to show na dapat may mag-exist. Okay? So this is called a non-constructive proof. Gagamit ka talaga ng mga results that were previously established. Okay? Now I'll stop here. I'll think about what you'll do on the lab, but definitely we need to adjust the deadline for the worksheet. Oh, by the way, guys, do you have questions on what we did today? Aba nag-scroll up ako. Feel free to ask questions. I think you can do problem 1. So, pwede nang hindi natin i-adjust yung deadline ni problem 1. And I think problem number 2 should also be fine. For every real number y greater than -2, there exists a real number x such that y equals 3 to the -2. Okay, I think you can do problem 2 as well. Number 3, okay, let's just take away problem 3 from worksheet number 4 para yung deadline niya ay sa October 11 pa rin. Okay, is that fine? Tingin niyo ba kaya niya yung gawin? So if you have, please try this too over the weekend or kung wala kayong magawa, try niyo na siya. And then sa Monday, kung may tanong kayo, pwede niyo siyang itanong sa lab instructors. Kung nahirapan kayo, tanungin niyo sila, sir or ma'am, ano po ba yung pwedeng susunod kong gawin? Okay? Mary, I think has a question. Go ahead, Mary.
Or pwede po yung constructive proofs po ba yun? Yung maghahanap na lang po ng value na masasatisfy? Pwede nyo na yung gawin both 1 and 2? Isa po lang po.
As a 2. Kung tama yung pagkakaintindi ko sa question mo, yeah, yung sa number 2 ay yeah, existence ang hinahanap niya. So kailangan makapagbigay kayo sa akin ng isang x na makakasatisfy nito sa kahit anong y greater than -2.
Sa 1 po.
Sa 1?
Ayan. Pwede pong mag-assign na lang po dyan na po.
Sa number 1, proof ng invalidity. So, alam natin invalid na kagad itong statement na to. So, una, symbolize nyo sila ng for all x, there exists some x, or kung ano man, parang existence to lahat. So, i-symbolize nyo muna siya. Pagka-symbolize, kasi sabi invalid daw yung argument. So, i-test nyo muna siya sa one-element model. Try nyo kung posible makakuha ng true implying false. Pagka posible makakuha ng true implying false sa truth value assignments kay P, kay L, at saka kay Q, then you're good. Pero kung sa one-element model, naging valid yung argument, then punta kayo sa two-element model. So consider kayo ng P of A, P of B, L of A, L of B, Q of A, Q of B. Bigyan nyo sila ng truth values para mapakita na true implying false. And hopefully, okay na siya sa two-element model. Huwag na kayong pumunta ng three-element model. Hindi ko lang tanda yung sagot dito, pero I hope hindi siya lalampas ng two-element model. Okay? Does that answer your question,
Right po,
Mary?
sir. Thank you po. Apo. Thank you
Alright,
po.
welcome. Any other questions? So if none, then let's
Sir?
call it a day. Yes, Victor?
Sir, so dyan sa proof, sir, do we have to show pa na that it doesn't work for one element universe before we go to two elements, or pwede na kaagad two elements na?
Pwedeng two elements na. So dun sa formal proof, dun sa proof, kailangan nyo lang ipakita na may nag-exist. So hindi nyo na kailangang ipakita, or mas okay nga na wag nyo nang ipakita because we are after elegance. So kung totoo siya sa one-element model, meaningless naman yon kung false naman siya sa two-element model. So I don't need to see ano yung nangyari sa one-element model kung napakita nyo na invalid siya on a two-element model. I just need to see the proof of invalidity. Right? Pwedeng sa scratch nyo na lang yon. Kasi wala namang grade yon kasi hindi naman siya nagmamatter. Yung kung valid siya sa one-element model. Alright?
Okay, sir. Thanks, sir.
Okay. Pero syempre, try nyo muna siya sa one-element model. Baka unnecessary yung pag-consider sa mas malaking universe. So, always start with the smallest. And if it works, then you're lucky. If not, then proceed ka dun sa next. Pero sa proof, ilagay nyo lang yung mismong case na naging invalid siya. Okay? Alright. Any other questions?
Ay, last, sir.
Okay, go.
So, assuming lang, sir, if it works for a one-element model, it works already for the rest of the element models. Ganun lang, sir. If it works for one-element model, it works for a two-element model rin. Parang ganun.
What do you mean it works? As pag invalid yung argument?
Yes, sir.
Pag invalid yung argument, posibleng maging valid siya sa one-element model, pero posibleng maging invalid siya sa two-element model.
Hindi siya
So,
pwede, sir, na okay na siya, di ba, sir, na invalid sa one element, pero naging valid siya sa two element.
so kung napakita mo na invalid siya sa one element, tapos napakita mo na siya ay valid sa two element, invalid pa rin siya. Kasi nakapagpakita ka ng isang universe kung saan invalid yung argument. Ang usapan natin sa validity ng argument, valid yung argument na quantified kapag valid siya sa lahat ng posibleng universe. So pag nakapagpakita ka ng isang universe kung saan siya invalid o isang model kung saan siya ay invalid, invalid na siya automatically. Okay, so does
Okay,
that
sir.
answer
Thank
your
you, sir.
question? Okay, yep. Okay, any other? All right, so probably I'll ask your lab instructors to discuss some proofs to you on Monday. So it would be great if you can attend the lab sessions. Also, you can consult with them if you have some difficulties with problems 1 and 2. I'll let them know na tinanggal ko na muna yung problem number 3 from the worksheet. So para alam nila na hindi nila kailangan hanapin yan. So yeah, thank you for coming today, guys. Enjoy the rest of the day and enjoy the weekend because this will be the last time we'll meet this week. So let's see each other again on anong araw na nga ba ngayon? On Tuesday, right? So bye everyone.
Bye, sir. Bye,
Bye,
sir.
sir.
Thank you,
po.
sir.
Bye po,
Thank you,
sir.
sir.
Thank you po, sir.